everyone, welcome back to another video of LeetCode Daily Challenge Streak Series, and in today's video we have a new question that says out of boundary paths. Now let's read the question. There is an m by n grid with a ball. The ball is initially at the position start row, start column, as in the start row and start column. You are allowed to move the ball to one of the four adjacent cells in the grid, possibly out of the grid, crossing the grid boundary. You can apply at most max move moves to the ball. Given the 5 integers m, n, max move, start row, start column, return the number of paths to move the ball out of the grid boundary. Since the answer can be very large, return it modulo 10 power 9 plus 7. Now let's understand the question. Now you'll be given a grid, you'll be given a starting position which has the starting row and starting column. We are supposed to return the number of paths, okay, the number of paths in which the ball can be moved out of the boundary. Okay, for example, if this is a grid and assuming that the ball is here, the ball can go out like this, can go out like this, can come here and then go out like this, can go here and then go out, then go here and then go out, then go here like this and this, and it can also move to and fro and then keep moving out. But here's the catch. Since you're also given the max moves, which is the number of max moves, as in from here, if the max move is equal to 2 in the question, you can only move 2 times by the time the ball reaches here. So it is at most 2 times. You can either move 1 time or you can move 2 times. Okay, so you move this way or this way. You come here, it's 1 and then it's 2 here. Okay, now let me explain it again. Now, you have a grid, you have a starting point. Now, since the maximum moves can only be 2, you can either go out of the boundary in 1 move, say here and here, or in 2 moves. As in, you can first come here and then go here. You can first come here and then go here, come here and then go here, come here and then go here. But you cannot go here directly, so you have to take other path. You can come first here, then here, then here. But here we are moving 3 times. You first come here, then here, then here. So it is taking 3 moves to go out of it. If you can like go back and forth and then move the ball out, you can like do it infinite times. So but that's not the question. So which is why you are given max number of moves in which you can move ball out of the boundary. Now, how can we solve this problem? If you carefully look at this problem, we are asked to find the number of paths. If it's number of paths or best number of paths or possible number of paths or maximum or minimum, what do we apply? What do we apply? We apply recursion. Now, how do we solve this problem? Let's talk about our base case first. Base case are of 2 types. One, the destination, and the other one is out of boundary cases. Okay, now what is the destination here? The destination is nothing but whenever ball moves outside the grid, as in the row value falls below 0 or the column value falls below 0, it means that you have your count 1, which is it is one of your paths. So anytime your row falls below 0 and column, so let me write a function here, function. And let's get back to the indices later. Let's write the base case first. So if r is less than 0 or c is less than 0, or there could also be a chance where you can come here and then go out of the box like this, which is it is more than the given number of rows. Okay, it is not only less number of rows or less column, it could be beyond the given number of rows or columns. So, or assuming that the rows to be m and columns to be n, if r is greater than m, if r is equal to m, because since we start from 0 and the mth row would be m minus 1 here, which is why r equals to m, or r is equal to n, which is the nth column, n minus 1. If it goes beyond that, this will be the nth place. So if that is the case, then we will return 1 in the sense we found our path. Now, what is one other base case? What is the other base case that we can think of? It is the out of boundary condition. Now, if you look at the question properly, since we are only supposed to complete this whole transaction within the mentioned number of maximum moves, you are supposed to finish the whole thing within the given number of moves. Now, so every time we perform an operation, we are going to decrement the moves. when we are considering one path, we are also decrementing the moves because we've already completed one move. That is why we've reached. So if you take this grid here, now you're here currently. Now if you want to go here, before going here, and you go here, when originally your moves were 2. When you moved here, now your move became 1. And then when you go here again, your move became 0. The minute the moves become 0, you will return 0, because when moves become 0, you don't have anywhere to go. If you are here, if it's one move, and then from here you come here, your moves have become 0. But did you find the path here? No, you didn't find the path. So if the moves become 0, you will return 0. Okay, now our base cases are done. Since the base case is done, how do we solve this? Now if we talk about the function, we can see that from one grid, you can either move upwards, downwards, or right or left. Okay, so it is very simple. So whatever this function is, now what will you have in this row? Since you are having row, column, and you're also checking the moves, you will simply talk about the rows, columns, and the moves. Okay, we'll simply talk about the rows, column, and moves. Now what is happening here? Now you will call the function. So if it is less than, if you reach the destination, you will return 1. Otherwise, what will you do? You will keep calling. Now since you are moving 4 directionally, you will explore all the 4 directions. So what are the 4 directions? You will go to the previous row, same column. You will go to the next row, same column. Okay, you will go to the previous column but same row, as well as next column but same row. And you are also keeping a count of moves, so you will have moves. Okay, moves and moves. Now remember that since the answer should be returned in mod, you're also supposed to do modulo for each of those. Okay, you're supposed to do the modulo function and then return the answer, since it could be very large. Now you're just calling the same function in all the 4 ways, and then you will return this answer. Now, what is the time complexity of this thing? It will be 4 to the power of m. How do you avoid this? Simply by using dynamic programming. By dynamic programming, you will be avoiding this thing. Now, what do you do? Now, typically, we have for one index, we use 1D, where -1 we initialize, and for 2D problems where we are keeping a count of I and j, we use a 2D array. But here in this problem, we are looking after R, C, and moves as well, which means we need a 3D array. Okay, 3D array. So what we'll do is that instead of having to set up the 3D array, since we are only pushing the values, okay, we don't have to update any value, we will just initialize an empty hash map, and every time we encounter an answer and every time we are trying to check, we will just update this value, update the row, column, and moves value in this cache or whatever this extra hash map is. So we will be updating this value in hash map, and we will be returning that updated value directly from the hash map. So before we solve this problem, before we get to this part, we write an extra condition. If R, C, moves are already in cache. You remember in the previous video we check if dp of ij if dp of ij is not equal to -1, then we'll be returning dp of ij. Since we are not initializing anything with -1 here and we are directly returning dp of ij here, instead of that, since we are checking R of since we are directly pushing that value into the cache, hash map, we are going to check if this thing is present in this cache. If yes, then we will return this value. Otherwise, we will compute this whole thing. Now, what will be the time complexity? Since we are using since we are computing O of n into m into max moves, okay, we are taking care of all these things, we are computing all these things. This will be the time complexity. What will be the space complexity be? Since we are using a cache map of the same size, like n into m into max moves, okay, as in the moves thing, since we are using the elements, the space complexity will be this, and additionally the stack space, the stack space of the same thing. Now let's quickly code this up. We have a function find paths given in which we have number of rows, number of columns, max move, start row and start column given. Now what are we doing first? Let's initialize the mod value to be 10 power 9 plus 7. Next, what are we doing? Let's initialize our cache hash map where we will be storing our row, current row, column and moves values. Now let's write our helper function. Since we are going DFS, depth first search, we'll be going from one element to the other. Let's write our DFS function. In this DFS function, we'll have our current row, current column, the number of moves that's left, and also the cache array to keep updating it. Now, what are we checking? What is our base condition? First base condition is the destination. What is our destination? If row is less than 0, if row is less than 0, or column is less than 0, or row is equals to m, or row is equal to n, okay, or column is equal to n. It means that the row is less than 0, column less than 0, or row value exceeded the grid value and the column also exceeded the grid. As in, this row value got out of this and the column, the row value got out of this and the column value got out of this. Now, what are we doing next? If that is the case, what are we going to return? We are going to return 1. Okay, we are going to return 1. What is our other base case? Our other base case is the out of boundary condition. What is our out of boundary condition? It is the moves getting finished. So whenever we go from one place to another, the moves gets reduced, correct? So if moves is equal to 0, okay, if moves equal to 0, then we will return 0. Now, what are we doing to solve the problem? Let's initialize a variable result equal to 0. Now, why are we doing this? Since we are supposed to return the answer in modulo, and every time we call this function here while exploring 4 paths, let's save that result while applying the mod for every case. Like when we go down, up and that, for every different scenario, let's calculate the modulo value and then save it. So let me show it to you here. So result is equal to, you'll be adding the result value previously here. So result plus, so instead of adding r minus 1, c minus 1, r plus 1, c plus 1 directly, I am breaking this down into 4 different steps to add the modulo to each of the values. Since it's Python, it might not compute the whole mod value at once, like it could be large. So I am breaking this down in smaller steps and then applying the mod value to each of those. Okay. So since I'll be applying the mod value, result plus, now what I'm doing, I'm going to call my DFS function for the previous row first, r minus 1, c, moves and cache. Okay, moves and cache. Now, before we initialize this, what are we checking for? If the current row, column, moves and this thing is already present in this thing. So if the current row, column and moves is present in cache, then we will return cache of, as in it's the frequency map here, we'll be returning cache of row, column and moves. Okay, next. Now we've called this function here. Now also you know that moves will be reduced by 1. So don't forget to write the part where you decrement the moves by 1. Now what you're doing in the end, you are just doing the mod value, computing the mod value. Now what I'll do, I will just copy paste this whole thing instead of having to write this so many times. 1, 2 and 3. Now here row minus 1, so this becomes row plus 1, and instead of row minus 1 I'll have column minus 1 here, and then instead of row minus 1 I'll have column plus 1 here. Okay, now I have this. Now what I'm doing, after computing this, in my cache of row, column and moves value, I'm going to store the result value. Okay, instead of writing this whole thing here directly, I broke them down into different steps because I will be able to compute their mod values separately. Now in the end, what I'm doing, I'm just returning this value that is stored here. So return cache of, okay, r comma c comma moves. Okay, now what am I doing in the end? What I'm doing while calling this original function, where am I starting? The row will be the start row, the column will be the start column. Okay, so I will be returning DFS of DFS of start row, comma, start column, comma, since it's max move in the beginning, max move, comma, cache as it is. Okay, now we have everything. Let's quickly run the code. This is accepted and let's quickly submit it. This works. Thank you guys.